Hi, and welcome to GeeksforGeeks. Today, we would be discussing the problem count BST nodes that lie in a given range. So, we are given a binary search tree and a range L to H that both are inclusive in nature. That means, suppose if 5 and 10 is given, where 5 is the L and 10 is the H, then 5 would also count in and 10 would also count in, non in between them, but taking into consideration in between as well as L and H also. So we are to find the count of number of nodes in the BST that lie in the given range. So let us first see what is a BST. So suppose we have a value, suppose we have a root node here. Okay. So if we move to the right side of the root node, then its value would be greater than the root. And if we move on the left hand side of this, then it would be less than the root. Now, there is one more thing to BST, that all the nodes or all the children should follow these two properties. Then only it is called as a BST. Okay. So now we are told that we need to find the nodes count. Okay. The first one is given as 5 and 25. So what we can do is we can just see all the nodes. If they are within the range L to H inclusive, then we would count in them in. So this is 10. 10 is greater than 5 and less than 45. So this would count in. Then we have again 5. 5 is the L itself and L is inclusive. So we would take in account. Then comes the 50. So 50 is greater than H and it is not within the range. So we would simply ignore that. Then we have 1. 1 is less than even L. So it is not within the range. Then we have 40. It is within the range. So we would have this. And then we have 100, which is much greater than H. So we would not count it. So in total, we have the count as 3 itself. So total count is 3 and we need to return 3. So the first and the foremost approach we can think of is, or the brute force approach is, that we can do a traversal, be it post, pre, okay, and in order also. We can do a traversal of in order, post order, or pre-order, and then we can simply traverse this. So traversing, the time complexity would be big O of n. But now suppose we want to improve over this. So to improve over this, we should go in the direction. Suppose we have this value as 5. This value would be, or let's take this example itself. Okay. Let us take this example. Here the L was 5 and H is equals to 45. Let's narrow it down a bit more, where L would be 20 and H would be 45. Fair enough? So suppose we started off from 10. So we know that from 10 on the left hand side, all the values would be less than that. So we won't be going there. So we are saving on time. And then we would be moving on this side. Now, if we are moving on this side, we know that 50. So we know that we need to go on the left hand side, because moving on the right hand side is not beneficial for us. Why is it beneficial? Because it is 50, which is much greater than H. So if we are moving in a direction which is much more greater than H, okay, already this value is already outside the boundary, and we are moving on the right hand side and making it more outside the boundary, then absolutely that is not beneficial for us. So we won't be moving in that direction. Okay, rather we were directly coming in. So we didn't need to check here, we didn't check here, so we can save this. Now we know that this is a BST, so we would use these all properties only. Now we would do as we are saying. So if the current value we are processing, if it is outside the boundary, or greater than that value, then what we would do is we won't go left. Okay, we won't go on the right hand side. Is greater than the range. Okay, or more specifically we can say is greater than L. If it is greater than the range or greater than the L itself. So in the same way, we would use these all properties only. Suppose the current value is greater than h, the range itself. Suppose it is from L to H. Okay, so 8 is greater than the H. So we know that moving on the right hand side would be more outside the H. So we won't go on the right hand side. Right hand side we won't go, but we would go on the left hand side. Then if the current value is less than L, if the current value is less than L, it is also outside the range. So it is lying somewhere here. So if we move on the left hand side, then it would go or this side. Okay. Then what we would do is we won't go on the left hand side. We won't go on the left hand side because it would become smaller. But we would go on the right hand side because it would become large. And if it is within the boundary, then we would traverse in both the children and we would increment the count also. Here, left and right, both would be applicable. Now, let us move to the coding part and it would be more clear. So this is just a small optimization. Obviously, in the worst scenario, the range would be such that it would involve all the values. Okay, but it would be better for average cases. In the worst scenario, the time complexity still remains big of n. Because see, the range would be from 1 to 100. Then all these values would come in. If all these values would come in, we need to traverse all the values. Then the time complexity would be big of n. But in the average scenario, we don't need to traverse all this. We can ignore them. That is why in average time complexity, this is better. Okay, let us move to the coding part. So in here, we are given the root, the L, and the H. So the first base case would be that we have traversed all of the tree. So if we have traversed all of the binary search tree, it would be null. So if root equals to the value null, then we would simply return 0. That there is no count that is lying here. Okay, the famous base condition of the tree problems. Now we would take the value because we would use it many a time. So int val is equals to root dot data. So first what I told is if it is within the boundary, then we would move to both the condition and we would increment one count. So val if val is greater than equal to L, okay, if it is greater than equal to L and val is less than equal to the value H, that means it lies within the boundary. So what we would do is we would first increment one count, then we would move to the left hand side as well as on the right hand side. I would just copy this so that it is more clear. So we would need to move on the left hand side. So root dash left and L and R would remain the same. And then we would again have this and we would move on the right hand side too. Okay. This would be H, not L and R. Left and right, I'm more accustomed to it. Okay. Fair enough. Now we go here. Else if. We go to the value else if the value is less than L, that it is within that range. So what we would do is we would simply not go to the right hand side as we have decided. If the value is less than that, we would not go on the left hand side, but we would go on the right hand side. We would do this only. Okay, that is get count and then root dash right and then L and then H itself. Fair enough. And then we would go to the else condition. If it is greater than the R, then we saw that we would move on the left hand side. Okay, we would move on the left hand side. The remaining condition, we would do that only. Either it lies within the range or greater or smaller. It is what would happen. So in get count of root dash left itself, L and H would remain the same. Okay, this returns integer. So we would simply return 0, but this won't be function. Okay, this is just for avoiding the compilation error we might get. Okay, we are getting correct root for the sample test case. Let us submit this and see if we can get an AC or not. And yes, we got an AC. That's it for today. Thank you and have a nice day. Now let us do a dry run of this code too, so that you would understand it much better. Okay, fair enough. So we passed with the get count. So I would simply reverse this with rec. Okay, so I would or simply R itself. So R of 10. I won't be writing the L and H because they are absolutely the same. L would be 5 and H would be 45. I won't be passing them. Okay, assume that it is passed. So 10 is not equal to null, so we would go down. Okay, 10 lies within the range. So what would happen is we would go to 1 plus rec of 5 plus rec of 50. Okay, then it would be done. Now rec of 5, we need to complete rec of 5. So rec of 5 is in the range. Okay, 5 is less greater than equal to. So if it is within the range, we are going 1 plus rec of, I'm just writing it right, rec of left hand side, there is no right hand side, 1 plus rec of 1. So 1 is outside the boundary, the first thing. So we would again go, if it is outside the boundary, 1 is less than L. So we would go to the right hand side. Right hand side would be null. If it is null, it would return 0. So it would go to 0. So rec of 5 is returning us a value 1. Then we would go to 50. 50 is outside the boundary. If it is outside the boundary, see, 50 is greater than R. Greater than R. So we would move to the left hand side. So it is telling me to move to rec of 40. Rec of 40 is within the range. So what we would do is we would have 1 plus left hand side, there is nothing. If there is nothing, that is null, then it would return 0. Left hand side would have already returned 0. Now let us move to the right hand side. There is nothing, it is null, would return 0. So this 1 would get backed off here itself. Then it would get back to 1. This is 1 plus 1 plus 1. That is 3. This is how the output to this is 3 itself. Now that's it for today. Thank you and have a nice day. If you face any issues regarding understanding this question, feel free to raise your doubts in the comment section. Thank you, everyone.